Hello everyone. In this part 2 of vectors, we are going to discuss some important terms related to vectors. So let's start with the A part, vector joining 2 points. Let us suppose we have the coordinate system of O, X, Y, Z axis, origin at O00, and we have P and Q 2 points whose coordinates are x1, y1, z1, x2, y2, z2. Then the position vector OP is given by x1i plus y1j plus z1k, and OQ is given by x2i plus y2j plus z2k. Then by the triangular law, what we are observing, OP plus PQ is equals to OQ. Then it implies that PQ is equals to, what is this, OQ minus OP. OQ minus OP, it means after solving this we will get this is x2 minus x1i plus y2 minus y1j plus z2 minus z1k. So this will be the vector PQ. And if we have to find out the magnitude, then the magnitude is always given by x2 minus x1i plus y2 minus x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. So this will be the magnitude of this vector. And if we have to find out the scalar components, then scalar components are x2 minus x1, y2 minus y1, z2 minus z1. If we have to find out the vector components, then vector components are x2 minus x1i, y2 minus y1j, z2 minus z1k. So this is the vector joining 2 points. Now let's come to the another point, direction, cosines and direction ratios of a vector. Same part, if we will consider a system of coordinate axes O, X, Y, Z with origin at O00, and we have the R is the position vector for this P. If this R is making, or this vector OP is making alpha, beta and gamma x angles with the positive direction of x-axis, y-axis and z-axis respectively, then the cos alpha, cos beta and cos gamma are known as the dices of this vector. And not generally, this is represented by L, this is represented by M, and this is represented by N. So L, M, N are the dices of this vector OP. And always remember this thing, with this figure what we are going to observe, cos alpha is equals to Z upon R, cos gamma beta is equals to, cos alpha is equals to X upon R, cos beta is equals to Y upon R, cos gamma is equals to Z upon R. It means we will have L is equals to X upon R, Y is equals to, what is this, M is equals to Y upon R, and Z, N is equals to Z upon R. Therefore we will get LR, MR and NR, which are known as the, these are the numbers which are known as the DRs of this vector. What is this? These are known as the DRs of this vector. Cos alpha, cos beta, cos gamma are known as the dices, and the numbers LR, MR and NR are known as the DRs of this vector. One important point you have to remember, that L square plus M square plus N square is always equals to 1. So this is the very important rule, that L square plus M square plus N square is always equals to 1. Now consider about this another thing. This is the section formula. This section formula is similar to that whatever you did in 10th class. Look at this thing again. For this, consider a system of coordinate axes. This is Z, this is, we are always taking, this is the X, this is Z and this is Y axis. So if we will take any 2 points P and Q, then the position vector of this P is, if we are considering this is P, this is Q. Then if this is the A, this is the position vector of this B, and if we will join this thing, and R is any point which divided into M ratio N, then we will get the position vector OR, this is vector R, is always given by section formula M into B plus N into Q upon M plus N. So this is the section formula if we have the internal division. But why this is the internal division? Because dividing point is lie on the line segment. If we have the external division, so again same process, this is z-axis, this is x-axis, this is z-axis, this is y-axis, this is the origin at 0, 0. Let us suppose this is the P point, this is the Q point, whose position vectors are A, and this is the position vector for this Q is B. And if we will take any point R which is outside to this and which divided into M ratio N, then the position vector R is given by, look at this thing, M into B minus N into A upon M minus N. So this is the rule for the external division. If this ratio is 1, 1, then we will get, this is the midpoint formula, and R is given by, what is this, A vector A plus vector B upon 2. So this is the way to write down a section formula in case of vectors. Now come to the very, very important point, scalar product or dot product of two vectors. Let us consider we have a vector A and this is the vector B, which are non-zero vectors and angle between them is theta. Then scalar product is given by A dot B is equals to magnitude of A, magnitude of B cos theta. So this is the scalar product of two vectors, and the condition is this: A and B are non-zero vectors and theta is greater than and equals to 0 and less than and equals to pi. Now we will consider some important points and observation. Look at this thing. If we will get theta, if we have theta is equals to 0, if theta is equals to 0, it means A dot B is equals to, look at this thing, cos 0 is equals to 1. It means this is magnitude of A and this is magnitude of B. For same vectors, look at this thing. For same vectors, what we are observing, very, very important rule, A dot A is equals to magnitude of A, that means A square. So this is the very, very important portion, that magnitude of A square is always given by A dot A. On the basis of this thing, if we will consider about the unit vectors of same axis, suppose x-axis, it means I dot I. I dot I means what, this become 1 into 1, 1. In the same way, this is for j dot j and this is for k dot k. Now another thing, if theta is equals to 90, you know very well, cos 90 is equals to 0. It means if we have the perpendicular axis, then the angle between them, the unit vectors, is 0. It means we have I dot j is equals to j dot k is equals to k dot I is always equals to 0, because these are the perpendicular axis and unit vectors along them is I dot j, j dot k, like this. That is why I dot j is equals to j dot k and k dot j I is always equals to 0. And this is also for j dot I, k dot j and I dot k. So these are the very, very important points. Now look at this thing. One more point we have to discuss. What is this point? Always remember this thing. Scalar product is commutative. That means A dot B is always equals to B dot A. So this is the very, very important thing. that scalar product is commutative. Now, what we are observing, if the angle between them is 0, it means, angle between them is 90, then cos 90 is 0, it means A dot B is always equals to 0 if the vectors are perpendicular. So if the vectors are orthogonal, then we have to prove that the dot product between these two vectors must be equals to 0. Or if already given that they are orthogonal, we can use this condition. Now, another point is projection of a vector on other vector. What is the meaning of this? Let us suppose we have these two vectors, vector A and vector B, and the angle between them is theta, and we want to find out the projection of A on B. What is the projection of A on B means? If we will draw the perpendicular on this vector from this point, then whatever the length perpendicular due to this perpendicular, whatever length is coming on this vector B, then this magnitude of this is known as the projection. So projection of this means we have to find out the magnitude of P. Now magnitude of P, cos theta is equals to, what is this thing? Base upon hypotenuse. It means we have cos theta is equals to P upon A. It means this become A into cos theta. Because we are discussing about magnitude only, so P is equals to magnitude of A into cos theta. Now you know very well, magnitude of A, cos theta is equals to A dot B is cos theta is equals to A dot B upon magnitude of A and magnitude of B. This AA cancel out. It means what is this? A dot B upon magnitude of A and magnitude of B. So this is the projection of vector A on B. And this is the rule to find out the projection of vector A on B is equals to A dot B upon magnitude of B. Now come to the solve or see the few questions. How will we do the solution? In question number 1, A part, what we are observing, we have magnitude of A is equals to root 3, magnitude of B is equals to 2, and the angle between them is 60. Find the A dot B. Now A dot B is equals to magnitude of A, magnitude of B into cos theta. It means this is cos 60. It means A dot B is equals to root 3 into 2. Cos 60 is root 3, cos 60 is 1 upon 2. Therefore 2 to cancel out. Therefore this is the A dot B for this part. Now we have to prove that for any vector R, prove that this is equals to this. Now for this, let R is equals to xi plus yj plus zk. First of all, we will find out R dot I. Now R dot I means xi plus yj plus zk. Now in dot I, you know very well I dot I is equals to 1, j dot I is equals to 0, z dot k is equals to, z dot k dot I is equals to 0. So I dot I 1, j dot I 0, k dot I 0. It means R dot I is equals to x only. Therefore we have R dot I into I is equals to, what is this? We have this is equals to x only. So this is the value of x. Similarly you can say, similarly we have y is equals to R dot j into j, z is equals to R dot k into k, and if we will put the value in this part, therefore we will have R is equals to x, R is equals to R dot I into I plus R dot j into j plus R dot k into k. So this is the answer for this part. Now let's see the solution of this C part. In this C part, they are giving A is equals to this, B is equals to this, then find the projection of A on B. Now projection of A on B, projection of A on B is given by A dot B upon magnitude of B. Now how will we get? A is, what is the A? 7i plus, what is this? J minus 4k, and dot, what is B? B is 2i plus 6j plus 3k upon magnitude of B. Magnitude of B means 2 square means 4 plus 36 plus 9. So if we will do the multiplication, 7 to the 14, I dot I is 1 plus 6 minus 12 upon 7. It means 14 minus 12, 2 plus 6, 8 upon 7 is the projection of A on B. So in this way, you have to solve the other questions also for practice. Don't forget to give the answer of this question in comment box. Thanks and God bless you.